made you do this before, but can you guys humor me and just, can anyone do like a logarithm graph in the air very quickly? You guys know how the logarithms look? Anybody? What? What does an exponential look like? Let's start there. Yes, this is what I want. Yes, right? So what's a logarithm look like? It's going to be the reflection like that. So logarithms look like this, yes? You guys with me? I need you to understand. Have I told you this? And this phrase sounds horrible, but it just is a reality. Pre-calculus is graphing hell. There's another way to say that, but its job is to make you graph the shit out of everything. So that when you get to calculus, you can make rough little sketches and do the calculus based on what you've sketched. Your sketches have to be good enough. So if you go through rigorous graphing everything, your sketches become much cleaner, you're not going to make simple mistakes. You guys with me? So you have to know the basic look of a function. What's going on right here? What's this all about? What's going on right here? What's that all about? This right here. What does that mean? What's going on? What's this? Sort of. But that indicates the presence of a
vertical
asymptote. Yes? So there's a vertical asymptote at
0.
x equal to 0. Yes, cool. In which case, if you remember, if you remember the shape of a log, and this is x equals 0, then you know the domain is, the inside's got to be positive. Because you know that there's only outputs when x is above 0. So the more you know the shape of a graph, the more you know stuff like domain, right? The more you know where the asymptotes are, the more you know how it kind of behaves. It grows very slowly over here. It grows really quickly, and then it grows very slowly over there. That's going to become huge in calculus, just knowing that kind of like basic idea of what the graph is. Okay. So if I want to graph, let's see. Yeah, we'll just start with this. If I want to graph this, and we already know the shape, because that's like the first thing we did was we graphed a log function before we knew it was a log function, because we just made the inverse of an exponential. Can somebody try to come up with some good inputs for this?
0.
0 is a bad input. What did we just say? Gonna use what's happening here? Asymptote at x equals 0. So can x equal 0 if there's a vertical asymptote at x equals 0? No.
I thought it'd be
You
1.
can't plug a 0 in because 2 to no power is 0. Yeah, obviously I want to plug 2 in. Okay. So I'm going to put 2 down here. 1. 1 is a good thing to plug in.
Can you do negative 1?
Can't use anything negative because, again, a logarithm looks like this. So it can't use any inputs that are 0 or below. Only exist for greater than 0, yes?
So half?
Half. Kick ass. Now, why did you say a half? Oh, it's beautiful.
It's not 0.
But more importantly, okay, it's not 0. Okay, I'm with you. You're like between 0 and 1/2. But do you see how 1/2 is based on the base?
Yeah.
That's why. If it was log base 3, I would have used 1/3.
Okay.
Okay. So what power do I raise to 2 to get 1/2? If I plug a 1/2 in, what power does 2 need to become 1/2? Negative 1. If I plug a 1 in, what power does 2 need to become 1?
0.
0. And if I plug a 2 in, what power does 2 need to become 2?
1.
1. So I have my 3 anchor points. And they are, if you think about it, they're the inverse of the points you would use for 2 to the x. They would just all switch because they're inverses of each other. So if I plot these points, I only need 3 points because I know the shape of it already. So let's do this. At 1/2, it's negative 1. At 1, it's 0. And at 2, it's 1. And I know there's an asymptote here, yes? I'm going to do this dotted, and you'll see why in a minute. So it goes like this. which is the exact thing you would expect because it's supposed to be an inverse of a function that does like this, yes? So you can see the symmetry, you can see the reflection. Maybe. So what do you think I'm going to do right now? I gave it away when I made that a dotted line.
Like
Transformations, kick ass. So how would I graph this function? Well, I have no other color options. Too bad, John. How would I graph this function here? Yes.
You
What are my transformations in the right order?
left 2, down 1?
Yeah, left 2, down 1. So if I just take every point and I go left 2, down 1, left 2, down 1. Careful here, it's in between, right? Left 1, 2, down 1. There. Where's my asymptote now? It was here. Where's it now? Negative 2, x equal negative 2, I like it. Because everything moved back 2, correct? So now it looks like it's got the same shape, it just looks like that now. Is that how we doing? I need you to realize we've done this before. It's just now I have a different shape to play with, but it's exactly the same steps that we did when we first talked about transformations, right? Transformations don't give a shit what the function is. They just always do the same thing. If I see x plus 2 inside of a funky ass function, I just take whatever the graph looks like and I move it that 2. You guys doing all right?
So
Yes.
we have a new asymptote, the other line. How did we get that?
Where was it to begin with?
It was at 0.
Good. And what did everything do?
Oh,
Everything went left 2, so the asymptote moves left 2,
okay.
and then it goes down 1. But if I have an infinitely long pole, right? If I move it down 1, it's like Goku's pole. You just move it down 1, it's the same thing. So I'm going to care about left and right when I have this vertical asymptote. Is that cool?
Yes.
So if I would have put x minus 3, the asymptote would have went to x equals 3. It would have moved right 3. Yes? Okay. I need you guys. So when you graph exponentials, when you graph logarithms, you must include the asymptote. You have to show me where that ends up. Did I actually start that?
Yeah, you were
Thank you. Don't trust myself anymore. All right, how you guys feel? I mean, there wasn't much to that section. That's basically it. All the same transforms can happen again. Yes?
Can we do one that's reflecting?
Sure. Reflecting on its own life? Okay. What kind of reflection? In fact, well, yeah, what kind of reflection you want? Doesn't matter?
It didn't matter.
Doesn't matter. Okay, I'll do this one. Bless you. In fact, I'll do this. Ha ha. So how many transformations are there? Ooh, make this log base 3 so it's a little easier to graph, yeah. Make it log base 3. Because in the log base 10, the points get kind of big and it makes it hard to graph. I won't do that to you. There's enough going on already. How many transforms do you guys see? 3. What are they in the right order?
compressed by 2. Or
Reflect around what? Y-axis. Because it's inside, left and right. It's going to be this kind of a flip that goes around the y-axis. Then, no. That's the last thing I do. Stretch by a factor of 2. Okay. Cool. Did we? I can't remember now. Can you guys try to graph the base function? Remember, make it dotted. I block some light for myself. Maybe that's better. Nobody's here, so ooh, that's much nicer. So, the 3 anchor points that you want to do for any log function, it'll always go through 1, 0. Any base log function will always go through 1, 0. Because when you plug a 1 in, you have to raise the base to a 0 power to make it become 1. So it always goes through 1, 0. Then it goes through base 1, because when I plug a 3 in, it takes one of them to make 3. So, and then it goes through 1 over the base, -1. So you always have those 3 points to mess with. And now I just do the several things that I just listed. I just do that to each point, right? Some of you guys don't give yourselves enough points. 1 point is not enough. 3. That's the skeleton. If you move those, then you put the, oh, that's terrible. Put the muscle back on. Just put the whatever. Okay. So the little base anchor points are just the skeleton of the shape. So what do I do with this? Yes, reflector across the y-axis. Then I, double the output. So stretch just means double. And then I up 1. There we go. So I reflected, doubled it, went up 1. Yes? This point, reflect. Twice 0 is, that's amazing. And then up 1. This point, be very careful. It's at 1/3 here, right? So if I reflect it, it goes right there. Boop. Do you see that? It's very close to the mirror, so it's like boop. And then it's going to get weird. Not too weird. What's the output right now? What's the output right now? Where am I at? -1. So I'm going to double that. Yes? Double it. And then I go up 1. So I'm right there. Where's the asymptote now?
Still at 0.
Yeah, because did it move left and right at all? Nope, it's still at 0. I love it, so it's still here. So I'm going to do like this. So normally a log is like that, yes? And now I just like doubled it, so it's a little bit more pronounced of a curve there. Okay. Is that right?
Anytime it's like a number in the beginning, like 2 there, it's always a stretch or a
Yes. So when it's outside, it does what it looks like. So it doubles it. If I put a 2 on the inside, it would actually cut the inputs in half.
and if it's like a fraction of
Yeah, if there was a 1/2 out front, it would smush it. If there was a 1/2 inside, it would stretch it.
and that stays the same for all.
Every function in the universe. Yes. Even functions I don't know. That's how it works. And there's a lot of them I don't know. So a single person can know them all. Yes.
So for this one, we use the x values to graph our base function was 1/3, 1, and 3.
Yes.
Okay, because
So
of the base.
if my base is B,
Yeah.
I'm going to use 1 over B,
Mm-hmm.
1, and B.
Okay.
Yes. Because those are the easiest things to do. And since we already know the shape, I only need 3 points because I already know it. So once I move the 3 points, then I just put the shape back on. Right? Yeah. Okay. So is everybody cool with that? If I would have put the negative on the outside, it would have just went like that instead, right? It would be like, whee. Yes? Okay. All right. So the main thing I want to talk about today. Let me ask you this. Just a review real quick. Do we know the properties of square roots that let us simplify this, for example? Can you guys remember? How do I simplify this?
4 and 5.
Yes, so there's a property of roots. There's a property of roots that says if I have the square root of two things multiplied, I can break them up. Yes? That is how roots interact with each other. So if I have the square root of 2 times the square root of 3, that becomes square root of 6. Because that's how roots work. Yes? So we have to know the properties of these functions. And we don't, unfortunately, someday I'll remember to do this, I don't say it like that. And then logarithms comes along and it feels like we're doing everything different. But it's the same shit. I have to know how logs work so I can do stuff like this. So this, of course, becomes that. Woo! Okay. So if I have, for example, what if I had log base 4 of 20, and I'm like, can I do anything with this? Do you see how it's sort of similar? And some of you guys might realize logarithms feel like roots, feel like radicals a little bit. They're not the same. Be very careful. Can somebody remind me, as we get into this discussion, this is where this becomes really important. The answer to a log represents what again? A power. So the properties of logs are exactly the same as the properties of powers. Okay, so for example, before we get fully into this, when I multiply like bases, what do I do with the powers?
You add them.
Add them. When I raise something with a power to a power, what do I do with the powers?
Multiply.
When I divide things with the like base, what do I do with the powers?
Subtract.
Subtract them, yes. Okay. So all those properties are going to show up in just a minute because logs are powers. So of course they have the same stupid properties. Now right now though, you're sitting there going, how the shit's that going to look? Which I understand. So I'm going to do this. I'm going to do something very, very strange. I always need to tell you when I'm about to do this. I am going to, right now, with your help, we're going to derive the properties of logarithms. What I'm about to do is nothing you'll ever have to do on your own. We're going to develop them and then we use them. Yes? You never have to derive it yourself. We're going to do it right now together. So we'll come back to this problem in a minute once we have ways to deal with it. So what if I kind of want to know, for example, I want to know what this is. That's basically related to this. In fact, let me make this base B. So it's any base. Oh shit. Let me make it base. Hold on. I don't want the B's to get confusing. So let's do this. Log base B of m times n. There. Okay. So I'm going to explore. I'm going to do some steps to see what this could possibly be. Because I know how square roots work. Square root of a product, I can just break them up, right? I'm very curious, what the hell happens with this? Not the same thing, because it's not the same function. So I'm going to do something very strange. And this is why I would never make you do this yourself. If I look at each of these on their own, do I know what like this is, just by itself? Does anyone know what this is? Good. If you did, I'm like, what level of reality are you on? So I'm going to call this, let's call it, no, my T's look horrible. Well, T's not bad. All right, I'll call it T. So what's log base B of n? I don't know. So let's call it, it doesn't matter, Jeff. Let's call it, F? Thank you. Was that a suggestion or was that you grading my... You get enough for today, man. You ain't making no sense. Alright, so all I'm doing, this is weird. This is why you would never have to do this yourself. All I'm doing is I'm like, okay, log base B of m times n. What if I could break them up somehow? So let me see. Log base B of m, I have no idea what it is. Let me call it T. Log base B of n, I have no idea what it is. Let me call it F. And right now, some of you guys may be like, you've made it worse, Jeff. You now have more variables than he did before. Good job, everybody. Round of applause for Math Boy. Can you guys rewrite this in exponential form? How do I do that?
B to the power of t equals
b
m.
to the t equals m,
B to the f equals
b to
m.
the f equals n. Amazing. What was it I was trying to investigate? Log base b of
m times
m times n. Now, can I write what m times n is now?
Yeah.
What is m? B to the t. And what is n?
b to the f.
B to the f. Okay, stay with me now. This is,
Um,
right now, this is everybody, now listen. I need you to separate two things. You have no idea why I did what I did. Right? You're not sure why. But I sort of was just like, here's parts of this thing. Let me just play with them. But does everything I've done after I made this choice, does everything I've done after that make sense? Okay. And I want to know what, and what is this, by the way? What is b to the t times b to the f? You told me earlier.
TF.
No. b to the
T plus F.
t plus f, yes? You add powers when you multiply like bases, yes? We know this. So what is log base b? This is what I wanted to know from the beginning, right? I want to know what this is. But now it's equal to this. This, I need you to realize, is easy as shit. Do you guys see why? I don't know what b, t, and f are at all, but I know what that is, right? What power do you raise b to make it become b to the t plus f? You raise it to the t plus f power, yes? Does everybody see that? Or you could look at it like, what do these two do? These two functions here, what do they do? They cancel each other, so of course the answer is that. Yes, yes, yes. Is everybody semi with me? You don't have to be fully with me, because derivations are always weird. What was t, though? Where did t come from? What was t from the beginning? What was t? Come on now, go back. What was t?
It was the power.
T was equal to this, yes? And what was f? Alright, here is a property of logarithms. If I have the log of a product, it becomes the sum of the logs. Why does this make sense? Remind me what a log is.
Power.
It's a power. What's the base for both of these? You can do it. What's the base for, don't overthink it. What's the base for both of these? B. So do they have the same base? And am I multiplying them? What do I do when I have two things with the same base and I multiply them? What do I do with the powers?
You add
What's a log again?
power.
A power. So when I have two things with the same base, I add the powers. It's the same stupid freaking property. Do you guys see that? I have two things, same base, multiplying, so I add the powers. Maybe. And do you see what I'm trying to do? I hate that there are math people out there that just go, they don't say shit up here, and they just go, here's the rule, memorize it. And you should hate that shit too, if you've ever experienced that. It's like, no, why does it work? What the shit are you talking about? And if you realize, I'm adding powers because I multiplied like, I already knew that. I knew that. It just looks weird because it's logs, but I already knew that shit. So, without going through the entire derivation, can anyone, let me write this again. So we just figured out this. Can anyone figure out what this would be? Yes, it would be log base b of m. What do I do in a divide like basis? What do I do with the powers?
You subtract them.
Subtract them. And it's exactly what it is. We could go through the whole derivation we just did, and we end up there. That's almost too beautiful to believe. And you're like, yeah, I don't believe it, whatever. So there's three properties, we have two of them. The third property is the most important property, but we prove it using the first property. So in that case, the first property is the most important. So let me start off like this. Let's do a concrete example first, and I'll show you. Here's a concrete example. Does anyone know what log base 12 of 3 is? Think about it. What would that require? What is that asking for?
12 to the what power?
What power does 12 need to become
3.
3? Now, let me ask it again. Does anyone know what that is? 12 to the what power is 3? Think about it for just a second. Now tell me, do you know what it is?
1/3? No, I'm sorry.
It's okay, you're okay, you're okay.
Stop pulling over.
Ain't no way we know, yes? The cube root of 12 is not 3, yes? Because that would be what a 1/3 power would do, you with me? So listen. The correct answer for me and you is I have no freaking clue. Jeff, I don't know what this shit that is. Maybe. I know it's between 0 and 1, because that's all I know. Because log base 12 of 1 would be 0, and log base 12 of 12 would be 1. So log base 12 of 3 is between 0 and 1. That's the best I could do. So don't feel bad if you don't know, because I don't know either. So you're like, what's your point, Jeff? You're just trying to make us feel bad? No. Does anyone know what log base 12 of 4 is? No. You just cut to the chase. Same reason, right? What power do I raise 12 to make it become 4? I don't have a freaking clue. Can we use the first property to rewrite this question? Because this goes both ways. Right? Be jealous of math. It goes both ways. So if I know I have the same base, somebody got my joke, and I'm adding them, how can I rewrite it? I can go the other way. Log base b of something plus log base b of something else, I can rewrite that as what?
Log.
So I'm going this way, yes?
So it'd be log 12 3 times.
Log base 12 of 3 times 4. What's 3 times 4? 12. What's log base 12 of 12? 1! I don't even know what this and this are, but I know they had to be 1. Which is neat. So that's one of the most immediate useful parts about these properties is I'm able to interact with things now. I now know how 2 logs interact with each other. Do you guys see that? So like I know how 2 square roots, if I multiply them, I know they do things and so forth. Now I know what 2 logs do when I add them. I know what they do now. If they have the same base. Gotta be careful, can't. What else you got, Jeff? I don't know. Okay. So, let me ask you here. What is log base 3? This is going to seem kind of silly. Of 3 times 3. Now we know what that's supposed to be, don't we? What's 3 times 3?
9.
Okay. If I use the property, let's just pretend for a moment that I didn't even realize 3 times 3. And I just went, oh, it's a property. How would I rewrite that using the property directly? And I still get, what's log base 3 of 3? And what's log base 3 of 3? I still get 2, of course. I mean, I don't care what I do first, it has to come out the same. So math has to be self-consistent. Since all those properties are true, whatever property I apply has to end up with the same answer. Now here's my point. Does anyone know how to rewrite this? Not that big a video. It's just a little extension on the property we already have. What do you think I would rewrite that as?
Log base 3 plus
Log base 3 of 3?
log base 3
Plus log base 3 of 3?
plus log base 3 3.
Yes? And we get exactly what we know we should. Log base 3 of 3 plus log base 3 of 3 plus log base equals 3. Right? 1 plus 1 plus 1. And we know log base 3 of 27 is 3. Yes? So here's my point. Here's the most important property, but it exists because we can prove it using the first property. This is going to look a little trippy. If I'm going to do log base b of m to the p. Do you see how this is 3 to the third? That would be log base b of m times m times m times m p times. Does that make sense? What does m to the p mean? M times n, how long? P times. M to the 7th would be 7m, so m to the p is pm's. Yes? Stay with me now. I'm still deriving. This is nothing you'll have to do because we have a shortcut coming up. How can I rewrite this? Same way we did up here. What would it look like if I rewrote it? Log base b of m plus how many times would it have log base b of m? P times. And of course, we kind of borrowed the word times to indicate what operation?
Multiplication.
Multiplication. So, I mean, 7 plus 7 plus 7 plus 7 is 4 times 7, yes? So what is log base b of m plus p of m? You can do it. P times log base b of m. I have, how many log base b of m's do I have? P of them. So I get plog. No, I'm kidding. I need you to see that, right? These make 2. One of these plus one of these is 2, plus another one is 3, plus all the way up to p of them, so I get p of them. What does it look like the power did?
Multiply.
It came down, yes? We finally caught up to you. Right? The power comes down. Why does it make sense? Do you guys agree that this has a base of b?
Mm-hmm.
So when I raise something with a power to a power, what do I do with the powers?
You multiply.
You multiply them. Can anyone, what's the log base b of m? That's a power, correct? And what's p? It's a power, correct? So when I raise something with the power to a power, I multiply the powers. Log is a power, p is a power. Same stupid freaking property, yes? It's the same property. Okay, maybe. Maybe? Screw you, Jack. Why is this the most important property? I'm not going to say yet, because I want to give you this. I use some different letters here, but you'll be okay. Go, sir. It's okay. Cancel what?
The power to it just comes down.
Yeah, there's nothing there that would cancel it. It forces me to have p of those, so I get p of those. There's nowhere that's making divided by p or anything. So what I want you to do, I want you to go ahead and do this. These little problems here. Feel free to work with people near you if you want to. These are not in my other class, because I never say what section I'm in, and I'm like, I just know shit. I don't know where it is. But you're right. That's my fault. As a teacher, I should tell you where we are. Pretty sure this is 6-5. What was I about to say? Oh, real quick. Do you guys see any difference between these two statements?
Yeah.
All right, you don't even know how big this is. This is what kills a lot of my calculus students. I'll give them this problem, and in calculus, this problem is easy. And they'll rewrite it like this. And I'm like, why did you change the problem I gave you? I didn't give you this damn problem. That problem's hard. I don't know if you guys understand. Do you guys see the difference?
Mm-hmm.
What's inside of the natural log on the first one?
E.
No, what's not the base? What's inside of it?
Parentheses,
Y plus 1 is inside of it, yes? What's inside of the second one?
plus
What's inside of the second natural log?
plus 1.
Stop saying that. What's inside of the natural log? 3? What?
Nice.
What's inside of the natural log?
Y.
Y. So this is natural log of y plus 1. This is natural log of y plus 1. Yes? Here's one that we're more used to. Is there a difference between these two?
Yes.
Which one can you do?
The second.
Yes, what's this one?
2 plus 1, 3.
This one?
Square root of 5.
Completely different shit. But I always get students, I give them this problem, and they're like, this is gonna grow. I'm like, no, it can't grow. What are you doing? Number one, that's not the problem I gave you. Number two, the problem you're making is worse. And then I'm like, why'd you make the test so hard? I didn't. You did. So, anyway, I'm sorry. So I want to make a big deal of that for you guys, because most of you guys have calculus in your future. That is one thing that just really makes problems harder when you like rewrite, put parentheses where they weren't any. If you're about to draw parentheses, you can stop yourself and go, does that change what this really is? Because it could make things really hard. Okay. And, here too, you can have. first one here, what do I do? How can I rewrite this?
Log of 3 base of 3 times 3 times x.
Huh?
3
Log base 3 of 3 plus. So just like we did square root of 20 and square root of 4 times square root of 5, and I do the one I can and I don't do the one I can't, what's log base 3 of 3?
1.
And what's log base 3 of x? I don't know. So leave it. Do the part you can, leave the part you can't. So that feels a lot like square root of 20, breaking it up into a part we can do and a part we can't do, right? B we did already. So, what about part C? 1.
Log base of 4 times 12 times 1/3.
Yeah, 1/3 times 12. And of course, 1/3 times 12 is
4.
4. And of course, log base 4 is 1. Okay. 1 is a favorite answer. I think it's plenty for today. We'll finish this one up next time. And then we'll get into the fascinating world of solving equations with logarithms and exponentials. Yay! Okay. All right. Anybody come in, not get their test back? You might have missed anybody.
I want to make this one. I just did not see it. It's going to have a lot of points.
It actually ends up being like 3.5 points because it was double. It doubled all the
Yeah,
points.
I just didn't see it. But it's
Yeah, so just make the correction, yeah. You need it back up to 97.
97.
97, yeah, you get 5 points back if you do the corrections, yeah. Hmm? Oh, I'm doing, okay.
Plus 2 or 0?
Do it again.
Plus 2 or 0?
Oh, I was gonna do plus 2 and then I gave you plus 3, just, even though this is not quite right, I just gave you plus 3 for everything. You see me? Yeah.
Hi.
Oh, homework? Yeah. You got your name and everything? Yep, okay. Thank you.
Okay. I emailed